All right, guys, today's warm-up says you apply a force to a bowling ball as you push it down a lane. The ball moves forward, but you remain stationary. And you have two questions here. The first one says, which experiences a greater force, you or the bowling ball? And the second question says, why? Okay, so question one, which experiences more force, you or the bowling ball? They're equal. Okay, they are equal. Again, and y'all listen up because people miss this every year. And even though I say it 12 times in a single day, somebody's going to miss it. Okay, but if you have two objects like the bowling ball and the person, again, force is an interaction between two objects. And so the forces are equal and opposite to each other. That's Newton's third law. For every action, there is an equal and opposite reaction. And so whenever you talk about the forces between you and the bowling ball, with whatever force you use to push the bowling ball pushes back against you. Okay, and so they are equal, even though the bowling ball moves forward and you really don't. Okay, so even though the motion is different afterward, the forces are equal. And again, why? It goes back to Newton's third law and what I just said. The force is an interaction between two objects. Okay, and so whatever force the bowling ball feels is the same force you feel. It's two halves of the same force pair. So please make sure that you have that down in your warm-up. Now, again, I'm telling you that somebody's going to miss it on the test. It's not the same question, but somebody's going to miss a third law question on the test because they're going to say, well, the bowling ball went forward and I didn't go anywhere. Okay, because that's what it says. The ball moves forward, you remain stationary. That doesn't change the fact that the force pair that exists between you and the ball is still an equal and opposite force. Okay, there are other forces that aren't part of that force pair acting on you. Your feet are on the ground. Okay, so there's friction between your shoes and the floor. Okay, there are other forces that are not accounted for there. So there are other reasons why you move differently than the ball does. But beyond that, we talked about yesterday that when you have equal forces acting on these objects, like the cannon and the cannonball was the example in the notes, that you're going to have different accelerations, okay, because you have different masses. And that would also be true. Even if you were to remove the friction, your motion would still have been different than the bowling balls because your mass is different. I do have a video clip in here to kind of illustrate the point further about why your motion is different afterward. And then I have a couple of things we're going to go over just for a little bit more practice with the third law stuff, because like I said, there are a lot of misconceptions that students have about Newton's third law. So I want to just go over some more stuff that you might see on your test, or at least something similar to it. And then for the rest of the period, and it should be most of the period, you'll have time to work on 401.4 third law problem set. Hopefully you have finished the older problem set, 403.3, but if not, today would be your last day to use a late pass on it. I did go over some of those questions with y'all in class yesterday, and I was recording it. I finished that recording during the day yesterday, so there is also in the playlist of videos on YouTube, there is a video of me working through all of 401.3 with the kinematics stuff. So if you have specific questions about that, just be aware that that resource is available to you and you can go and look at it. The other thing that's up here is unit summary practice. Guys, this is the last day of new material. Whenever you come into class on Monday, you're just going to have a review day. And then on Tuesday, you're going to take a quiz. We'll go over that. And then Thursday will be your test. Okay, so there's no new material after today. You have everything that you need in order to be successful, but use that unit summary just for some extra practice. But beyond that, it is bonus points. It's also a daily grade redo in case maybe it didn't go so well on one of your daily grade assignments. So again, let's go ahead and look at this bowling ball video that I have, and then we'll get into the rest of the notes for today.
You're pushing the bowling ball, and you've kind of frozen at the point at which you're going to push the bowling ball. So you apply force into the bowling ball, and it's going to apply an opposite and equal force back on you. Now, the ball's going to move, but you're not going to move. And the reason why is you're applying a force against the floor, and it's applying a force back on you. So you don't move, but the ball is going to quickly move away like that. Let's do a scenario again in space. What happens? You apply force into the bowling ball, it applies an opposite and equal force back on you. What's going to happen now, there's no ground, you're both going to accelerate away from each other. Why don't you move as fast as the ball? Because you have a greater mass.
Okay, so that summarized what I was just talking about, but he has a whole video here. You're welcome to watch the entire clip on Newton's third law if you want to look at just one more resource. But again, there are other forces at play outside of the force between you and the bowling ball, like your shoes on the floor, and that's going to partially explain why you're not moving, but that doesn't mean that the force between the bowling ball and you isn't equal and opposite. It is still an equal and opposite force because it's an interaction between those two objects. Okay, so anyway, that is there if you want to look at it some more, but I wanted to go over kind of the same idea that we talked about in the warm-up. Here's another question. You're going to see one like this again, so it would be a good one to write down in your notes. It says, write out the action-reaction force pair for the following scenario. Again, when we talk about these force pairs, I've been talking about two halves of a force pair, but you could see the question worded like this, where it says, hey, here's the action force. Edwin pushes left on cart C. What is the reaction force? Okay, so what is the accompanying force, other half of that force pair? Okay, so take a look at this diagram. There are 3 shopping carts here labeled A, B, and C, and I named this old man Edwin. But it says Edwin pushes left on cart C. So what would the reaction force be to that force? If you're not sure, take a moment to think about it, or take a moment to turn and talk to your neighbor. You got 21 seconds to discuss, but see if you can come up with an answer. And be ready in case I call on you. All right, Callie, what did you and Emily come up with?
We said that A and B are going to move to equal force.
Okay. While that is true, that A and B would also move, that is not the reaction force. It will, however, on a multiple choice test, probably be an option. Okay, don't pick it. Okay, it's a true statement, but it's not the reaction force. Does anybody have a different answer? What they think would be the reaction force? Yes, Nate.
Would C push back on Edwin?
That is exactly what you would put. Cart C pushes back on Edwin. Okay, so if Edwin pushes on cart C, remember when we wrote our force pairs out yesterday, we had to have the same 2 objects in it. Okay, so if it was Edwin pushes on cart C, then the other half of that is cart C pushes on Edwin. Now, yes, C is going to push B, which is going to push A, but that is not the other half of the force pair. Okay, so please make sure that you understand how to answer a question like this. You will see it again on your quiz and on your test. Okay, again, not the exact same thing, but the same idea. So write down what you need to so that you know how to write out or to select from a list of multiple choice options the reaction force in a scenario like this one, or any scenario. Yes, sir?
When's the quiz?
Your quiz is on Tuesday. All right, any other questions about this? All right. Here is another example, and again, you're going to see something like this again, so write it down. It says, while driving, Miss Darwin observed a bug striking the windshield of her car. The bug hits the windshield hits the bug. Which of the 2 forces is greater? The force on the bug or the force on the windshield? I heard a couple people shout it out already. Okay, which one's greater?
Equal.
They're equal. I'm aware the bug not going to come out of that okay. Doesn't matter. It's still an equal and opposite force. Okay, so again, if you have 2 objects, you're going to have colliding or otherwise pushing or pulling on each other. The forces will be experienced by both of them. Okay, so they're going to have equal and opposite forces. Now, your car has a lot more mass than the bug. So your car is going to have almost no change in its motion. Okay, tiny acceleration, negligible. The bug, on the other hand, very large acceleration. By the way, very large acceleration, not good for anyone. Okay, if you have a very large acceleration, okay, then that's how you end up with injuries or in a car crash, potentially fatal car crashes if your acceleration is too great. Okay, because you're moving a certain speed. If you stop like on a dime suddenly, and you collide with something, that is a very fast acceleration. Okay, same thing for the bug. You don't want that. Okay, but the forces are equal. Okay, the follow-up question I think is what experiences a greater acceleration? We just talked about that. The bug experiences a far greater acceleration because you're driving along, let's say 50 miles per hour when you hit a bug. You're still going 50 miles per hour after you hit the bug. It doesn't really change your speed. Okay, but the bug, it was flying whatever it was flying beforehand, but guess what? Afterward, it's now going 50 miles per hour in whatever direction you were going because it is now on your windshield. Okay, so it has a very large acceleration because its velocity is going to change drastically due to that same force that your car experiences, but it has much less mass. Are there any questions about that? I'm hoping we have that down. Okay. Because again, very common misconception. Again, because the larger the mass, the less the acceleration because the forces are equal. So the force of the car equals the force on the bug. The car has a large mass and therefore a very small acceleration. The bug, on the other hand, has a much smaller mass and therefore its acceleration must be much larger. Okay, so again, same idea. Sorry, I didn't realize I clicked the timer. All right, I told you there wasn't much for today. That's pretty much it. We've already covered everything. I was just going over a few more things. So today for the rest of the class period, you have time now to work on 401.4 third law problem set. It's due tonight, okay? But you should be able to finish it in the room. Again, if you didn't finish the one from the other day, you might want to also use some time to open that up and ask questions about that while you're in here. Once you finish the assignment for today and your assignment from the other day, assuming you're done with both of them, then I'm going to recommend that you work on your unit summary. Again, it counts for up to 5 bonus points on your test, which is next Thursday. It's up to because we're just going to divide your score by 20. It is still a CFU redo if you need one. Okay, so I'm going to go ahead and stop talking, let you guys get to it, open it up. If you have questions, please let me know.